In this video, we are going to use what we learned about logarithms to solve some equations that involve not just logarithms, but also exponents. So we're going to review some of the basic properties of logarithms, and then we're going to demonstrate how to use these properties to solve some equations. So recall that if we have a function f of x equals a to the x, then as long as a is positive and not equal to 1, then it's going to have an inverse, and that inverse is going to be given by f inverse of x equals log base a of x. And here are some things that we know about the log base a function. So first of all, we're just going to use the fact that we know f inverse of f of x equals x for all inverse functions. And since f inverse is log base a and f of x is equal to a to the x, we get log base a of a to the x equals x. This works the other way around as well. We get a to the log base a of x equals x. If we want to think of this as flipping the x and y in an equation, then if we have y equals f of x, that means that x equals f inverse of y. Applied to the two functions that we have, that means if y equals a to the x, that means x equals log base a of y. And of course, this works in reverse as well. If y is equal to f inverse of x, that means x equals f of y. And of course, that means if y equals log base a of x, we get x equals a to the y. Now, for solving equations, the most important properties are the following. Log base a of a to the x equals x, and a to the log base a of x equals x. These are the ones that tell us that log base a and a to the x, they both cancel each other out, which is something that's useful to do in equations. We've been doing it actually all the time with other functions. And if you ask me about that in class, I'll be glad to demonstrate on some of the other inverse functions as well. So let's say we want to solve the equation 3 to the 2x equals 25. If we want to look to the above for some help on that, well, first of all, we notice that we're talking about the exponential function. We're looking at 3 to the 2x, so we're looking at the exponential function 3 to the x. So let's just put in a equals 3. And now, instead of having 3 to the x, we actually have 3 to the 2x in our equation, so let's replace all the x's with 2 to the x. And then notice in that left-hand side of the equation, we have exactly 3 to the 2x. And also notice that when we put that 3 to the 2x into the log base 3 function, the exponents cancel each other out, and that 2x just shows up by itself, which is really nice because if we had 2x by itself, it would be pretty easy to solve for x. One of the things that makes this equation difficult to solve, the 3 to the 2x equals 25, is our x is trapped in that exponent. So a good idea for us to do is to plug both sides of that equation into log base 3. When we do that, we're plugging the same values into log base 3. It'll still give us an equation. So here we have log base 3 of 3 to the 2x equals log base 3 of 25. The left-hand side is going to simplify to 2x because of the, if you look way on the top, the upper left equation, we get log base 3 of 3 to the 2x is equal to 2x. So we end up with 2x equals log base 3 of 25. And now it's going to be a piece of cake solving for x. We just divide both sides by 2 and get x equals log base 3 of 25 divided by 2. And that enables us to solve for x. Now, another type of equation we can have is one that not just involves exponents, but involves logarithm functions. So now let's suppose we have log base 2 of x plus 3 equals 6. We're going to play the same game before. Notice we're looking at the log base 2 functions. So in those equations above, we want to look at where a is equal to 2. And we want to have log base 2 of x plus 3. If we look on those top equations to the right, notice we have log base 2 of x. If we turn all the x's into x plus 3, then that same equation is going to have log base 2 of x plus 3. Now notice in that same equation, we have 2 to the log base 2 of x plus 3 equals x plus 3. Putting that log base 2 of x plus 3 in the exponent of 2 will cancel out the log base 2, and that x will be freed from the log function. So it looks like what we're going to want to do in our equation in the example is put both of those numbers in the exponent of 2. So we're going to put each side of that equation as a power of 2. It's still going to be an equation because both of those are 2 to the same power. And then if they're 2 to the same power, they have to give us the same number. Now on the left-hand side, that of course is going to simplify to x plus 3 because of our log properties. So then we have x plus 3 equals 2 to the 6, and now solving for solving for x is going to be a piece of cake. We just, well, first of all, note that 2 to the 6 is equal to 64. Now we have x plus 3 equals 64. Now all we have to do is subtract 3 from both sides to get x equals 61. So now you have an idea about how to solve these logarithm type equations. Look for the activities on the PDF file included with this video.